In this video, we're going to be talking about using properties to simplify expressions. So I have a lot on the board. I want to go through it. It's going to be helping you to understand properties. And there's three properties I want to deal with today: commutative property, associative properties, and identity properties. Okay, so let's go through those. They're on the board here. Commutative properties, order for adding or multiplying. If it's all adding or all multiplying, the order in which you do it does not change the sum or the product. For example, 7 plus 4 is equal to 4 plus 7. Doesn't matter which way I add them, it's going to be the same. Using variables, I could say A plus B is going to equal B plus A. Always equal. Doesn't matter. If you have A and an A, a B and a B, it'll always give you the same total. They'll be equivalent fractions. Equivalent expressions, I'm sorry. Okay, so that's with adding. If you have all multiplying, doesn't matter the order on this either. You have 4 times 6 and 6 times 4. It's going to be the same. 24 over here, 24 over here. So you could say A times B is the same as B times A. You're going to get the same product, the same answer, no matter how you multiply them. That's commutative properties. Okay? Associative property. It says the way three numbers are grouped when they are added and multiplied doesn't change the sum or the product. Okay, so it's all adding, all multiplying. For example, 3 plus 9 plus 4. And I have parentheses here, so I do the 3 plus 9 first, and then I add the 4. Well, over here I have 3 plus 9 plus 4. Same exact order, 3, 9, 4, 3, 9, 4, but I've grouped them differently. I'm adding this first over here, I'm adding this first over here. But it doesn't matter how I group them. They're going to give me the same. So the associative property says no matter if they're in the same order and they're all adding or all multiplying, if you group them different, you're still going to get the same answer. So using variables, you could say A plus B plus C equals A plus B plus C if you group these first or if you group those first. They're going to be equivalent fractions. You're going to get the same answer. Okay, that's addition. And then multiplication, 8 times 5 times 7 equals 8 times 5 times 7. If I group these first or if I group these first, it doesn't matter. I'm going to get the same answer. It's all multiplication, and so you can see with my variables, A times B times C, I can do AB first and then times it by C, or I have A times B times C, I could do BC first and times it by A. It's all multiplication, doesn't matter which is grouped. Okay? So commutative, adding and multiplying, doesn't matter which order. And then associative, doesn't matter which is grouped first, if it's all adding or all multiplying. Okay, let's go over here. Identity properties, right here. This says a sum, and you guys know this, a sum that is added to 0 is always the other number, or the addend. So for example, 10 plus 0 is going to be 10. So you could say A plus 0 is always going to be A. Anything added to 0 is the other number. Okay? And the property of a factor and 1 is always the factor. So for example, if I have 10 times 1, it's always going to be the other factor. Not the 1, the other one. Okay? 10. So you could say A times 1 is going to be A. All right, you know these things. Anything plus 0 is going to be the other number. Anything times 1 is going to be the other factor. And that's called identity properties. Now you have a name for what you've been doing for a while. You understand this, and now you can say, oh, that's the identity property. Okay, let's look at some problems over here. I have to see if these are equivalent fractions, or equivalent, I don't know why I keep saying fractions, equivalent expressions. And if they are, I can tell you why they are, okay? I can solve them, but I can also look at that. I see that this is 15 plus 5 plus 8, 15 plus 5 plus 8. It's all adding, but it's grouped different. And just because it's grouped different doesn't matter. It's in the same order. It's all adding. It's going to be equal. Okay? And now let me prove that to be true. I do parentheses first. 13, bring down my 15. 15 plus 13 is 28. 15 plus 5 is 20, plus 8, 28. 28 is equal to 28. Okay? Didn't matter the grouping, but because of the associative property, this makes it equal. Equal expressions. Okay, let's go down here. I have 20 minus 12 minus 3, 20 minus 12 minus 3. Same numbers, same order, they're grouped different. My first instinct is to say these are going to be equal because it is associative property. They're grouped different, but they're the same numbers. I think I would say they are equal, but I'm going to do it. And maybe you already know what the problem is here. 20 minus 12 is 8 minus 3. 8 minus 3 equals 5. Now I do the parentheses first. 12 minus 3 is 9. 20 minus 9 is 11. 5 and 11 are not equal. It looks like I have the associate property here, but the associate property can only be adding and multiplying. You can't do the associative property with subtraction or division. It will not work. So when you see these same numbers grouped differently, because they're grouped differently, you will know they're not equal. Not equal. Okay? Now let's look over here. 34 plus 0, 34. Now we know before that was good, that equals. We know 34 plus 0 is 34. But now we can say, oh, this is true because of the identity property. Okay? This one, 20 divided by 5 and 5 divided by 20, looks like the commutative. Doesn't matter what order, should be the same. Let's try it. 20 divided by 5 is 4. 5 divided by 20 is 1/4. Okay? Much different. Much different. So this is not equal. And the reason why it's not commutative because commutative can only be adding and multiplying. Okay, so we have commutative and associative. Those two properties can only be adding and multiplying. All right, let's go back over here. Okay, let's do a couple problems. And I can show you how to use these properties to help solve problems. Our learning target is still using properties to solve expressions, or simplify expressions, I should say. Okay, so there's one, like a word problem. Could say the Bulls had 15 guards, 4 centers, and 3 forwards. Okay, so the Bulls had a big team. They got 15 guards, they got 4 centers, they got 3 forwards. How could I write 2 expressions that are equivalent using the associative property of addition? Okay, so I could say I want to find out how many members are on the whole team. 15 plus 4 plus 3 And maybe I want to do the guards and centers first. Okay, if I want an equivalent expression, 15 plus 4 plus 3, this time I'm going to do the centers and forwards first. Okay, I'm going to group them different. This is one way to show the associative property of addition. Okay, I can know that these two are equivalent. All right, let's do another one. This will be our last one. Okay. I'll use this example from the book. They have a slide here. See if I can do this. You go up the stairs, the ladder, then you go down, and then like this. Okay, and then this is 12 feet, and this is 15 feet. Okay, and it says the area of a triangle can be found using this expression. So they've kind of created this triangle here that we want to find the area. Okay, we're going to find the area of this triangle, and the formula for this is 1/2 times base times height. Okay, find the area of the triangle. So let's replace base and height, B and H, with the actual base and height. So the base is 15. So 1/2 times base, 15, and then the height is 12. Okay. Now, using the commutative property, I could change these around a little bit. Could be 1/2 times 12 times 15. Okay? And these two here are exactly the same, are equal. But let's figure it out. I mean, I know they are because commutative property of multiplication tells me it doesn't matter what order they're in, it'll all be the same. So let's see. I could do, if I do this way, 1/2 times 15, that's going to give me 7.5, and then 7.5 times 12. I don't like to, it's a little bit harder. I could use my calculator. I could also do 15 times 12 and then times it by 1/2. I'm looking at this way here. Because I know these are equal and I can do it this way, I like this way better. 1/2 times 12. 1/2 times 12. I know that really easy. 1/2 of 12 is 6 times 15. Okay? And then 6 times 15, I can come over here and do 15, 6. I could use my calculator, but I can do it easily like this too. That's 30, and then that's 90. Okay, so it's 90 feet squared. Okay, 90 feet is the area. Using this formula, 1/2 times base times height, but you can look at something and say, oh my gosh, I don't know how to do this. But you say, oh, I do know that I can switch these around. If I think it's easier to do 1/2 of 12, I'm going to flip them like this, and they're the same numbers, they're just in a different order. Commutative property of multiplication. Okay? We'll go over lots of these. We're going to practice this, and we're going to use these properties to simplify expressions. We're going to use the commutative property, the associative property, and the identity property, and they will help us. And again, we're building this foundation for working through algebraic expressions.